13 of... Oh. What did I just do? Okay, let me zoom in a lot. I'll do, I guess. Excuse me. Too quiet. Alright, what are we doing today? That's way too much. Okay. Finally got audio to work. Oh, it zooms in for all the tabs. Know that. Okay, yeah, finally got audio to work. Excuse me. Yeah. There's a bit of a... I don't think that'll get old. I enjoy that quite a lot. Okay. You know what? Nah. There's enough to do here. And this to render a kit release, maybe. Could be useful. Still have to do that later. I think this might also come later. Maybe we can move on to the next day, because I've moved the audio part out. But I'm thinking this could be part... I don't know. I guess this could be removed later. Sample rates. I don't know yet. I think that could be better, but I don't know how.
The stream begins now is to begin the stream. I think we can all agree on that. All right, everyone, thank you so much for joining us again. This is Handmade Hero Day 13, where we are making an entire professional quality game from scratch right before your very eyes. We are in the middle of a process where we are basically taking our Windows code, which is what we did the first 2 weeks, and we are turning that into platform independent code with just a little Windows layer, and that'll set us up for success kind of going forwards, where we can have this run on lots of platforms and we won't have to touch any of the code that is in the mainline game. So we left off yesterday. We had just moved sound output over from being platform specific to being platform non-specific, and so today we actually have to do the same thing for input. So basically what we're going to try and do is we're going to try and end the day with having input being processed on the other side. Now there's one little thing that we may cheese out today because I want to talk about it in depth tomorrow, but we're going to do most of the work for the input today. So loading up Win32 Handmade, this is our Win32 code here, and then loading up handmade.h and .cpp over here, which is our platform non-specific code. Basically what you can see, what we've already done, is we're already passing some generic structures that just are the off-screen, the graphics buffer, and the sound buffer to the game, and then the game fills those in. But what you can see here, obviously, is that we're still having to pass in things like blue offset and green offset, which are essentially, they are allowing the platform layer to process the input from the gamepad or the keyboard or whatever, do whatever it's going to do, and then pass that information to the game so that it can render the off-screen buffer. But you know what? This is kind of interesting here. Let me finish what I was going to say, but then I want to show you something else, something a little fun. But what we're not doing is we're not actually passing the input across and letting the game do that processing. So all of the actual results of the input processing are still sitting in our Win32 code, and we don't want to do that. We want to have all of the logic for processing the input on the platform independent side, and we just want the Win32 code to do the work necessary to sort of like process it out of Win32 format into some convenient generic format that all platforms can provide, hand that over to the game, and then go from there. So that's what we're going to do. I want to say one thing. Now you'll notice if I cut and paste this here, we didn't notice this. No one on the stream noticed it either. See anything going on here? The definition for our function is here, but the declaration, the forward declaration up here, is missing this. It doesn't have int tone, right? So how did that work? What happened there, right? Shouldn't we have gotten some kind of error? Well, the answer is that actually in C++, anyway, which is what the mode we're compiling in. We're compiling mostly what is C code, but we are compiling in C++ mode, so we can use C++ features when we want to, if we want to. One of the things we get in C++ mode is function overloading. And what that means is you're allowed to define multiple functions with the same name that take different inputs. So for example, I could define many different functions, each of which took a different set of parameters. You can see what I'm talking about here, for example. Each of those is different. I can compile this, and it is totally legal. I can make each of these be its own function, and there's no problem with that. Totally legal. No warnings, no errors, no nothing. It is flat out completely legal. Get that up there above my window so I can see it. There we go. And so you may ask yourself, well, and this one actually is a duplicate because, well, okay, you know what? It's good that I did that. I can tell you why it's duplicate. Basically, you may ask, how does it know which one to call when you go to call one? The answer is it just matches the parameters and sees which one matches. So if I go down to Win32 Handmade, where this is called, game update and render, you'll notice that I'm passing 1, 2, 3, 4, 5 parameters. So it's just going to look and say, oh, okay, of all of these, there's only one, right, that actually takes that many parameters. Sorry, did I say 5? That's 5. 1, 2, 3, 4, 5. Yes, that's right. And this is 1, 2, 3, 4, which doesn't count. This is 3, this is 3, this is 2, this is 3. So the only one that counts is this one with 5 parameters. So it's just going to go, oh, it's the 5 parameter one, and try to call that. Now, things can get a little more complicated if we have ones that have the same number of parameters. So let's say we had 5 parameters in both of them, but I had this one be a float, like that. It still would work in theory. Let me get rid of this guy, because I'm not going to talk about him yet. It still would work because most of the time, the compiler will be able to tell that you were trying to pass an integer, not a floating point, so it's going to call the integer one, whereas if you passed a floating point, it would pass the other one. So you can see that basically it's going to do its best to kind of match those up. But sometimes it doesn't know which to do, and then you will get an error, and that's that one that I deleted here. So let's say I have int green offset and int blue offset, and that's the only difference between these two functions. Well, which one does it call if I pass it, a buffer, an integer, and then the sound buffer? The answer is it has no idea. It does not know how to differentiate between those two because they both take an integer, and so that is an error. You would have to change one of these or rename one of these in some way in order to differentiate them in a way the compiler understands. That's the simple capsule overview of function overloading. Basically, I don't use function overloading a whole lot, but I do like having access to it. It's one of the reasons I like compiling with CPP files. I don't know if C99 let you start doing function overloading or not. I've never really looked at the C99 spec. But C++ lets you do it, and it's one of the things that I like as compared to C. One of the reasons I like it is because it allows me to basically have a few different ways to call the same function without having to have different names for them. And it just makes things a little more convenient and easier to read in a lot of cases. So I don't go hog wild with it, but I do like it, and I think it's a useful feature. Something to be aware of there. So anyway, what was happening here is we just had a completely erroneous declaration. This is not a function that ever existed. and I just forgot to update it here. We don't need to actually put this here. It is strictly sort of for legibility. I like kind of sticking things together so I can quickly look at what the definition is of my platform layer. But basically, like, we don't even need this here. We could have it be completely not defined at all, because since handmade.cpp gets included before win32handmade.cpp, we are totally fine. It'll pick up the actual definition here and doesn't need a forward declaration at all. So, I hope that basically works. And Jagger27, I know my face hides the code, but I can't see that code either. I can't see it now. It's blocked for me as well. So I promise you it will never hide code that I can see. It'll only hide code that I can't see either. All right, so moving on. Basically what we've got here is we have a situation where we need to extend this so that it starts taking input. So the first thing I'm going to do is I'm going to basically pull out these guys into statics because I don't want to get to memory yet. Like I said, that's going to be the topic of tomorrow's entire thing unless we somehow speed through input tonight, which I don't expect we will. I expect there's plenty of explanation to do there. So all I'm going to do is I'm basically going to pull these out here, and I'm going to basically make them be equal to whatever they were by default. So the x offset, y offset here that were equal to 0 before, I guess we'll just leave them as 0 now. That's what they would have been initialized to anyway, but no big deal. Tone hertz here was 256, so we'll go ahead and make that 256. I'm going to go ahead and nuke that from this, as well as the tone volume, because those should not be used anymore in the platform code. Tone hertz and tone volume are gone. I don't know if we use running sample index. I believe we still do out here, correct? To figure out where to lock, yeah. So I think that's basically everything that needs to be removed from that struct. Let me go ahead and pull that struct out to the top as well. I tend to like to have these up here. In fact, what I usually like to do as well is I usually like to have an H file even if I don't need one, and I like to kind of put that stuff in there so I can quickly see it, quickly flip between it. So I may just go ahead and straight up do that, right, like that, if that makes sense. So basically the wave period, that's also should be gone, so let's get rid of that. What else do we need to ice? These two, not going to happen now. We're going to have to do those ourselves. Tone hertz, that's not going to happen. Got to get rid of that. And the wave period also, all that stuff's going to have to be dealt with differently, and we're not going to pass them anymore, so we're basically just down to this. And now we get to a situation where we've done a little bit of feature regression there. We have removed all of the ability to control what's going on, and we're going to have to start moving that into the platform layer. So there we are, everything's still working, but we cannot use our joystick anymore. Basically, if I go ahead and pull out our lovely pink joystick here, this guy, does not matter what I do. I can mash on that all day long, and we're not getting anything from our game. So now what we need to do is we need to decide basically what we're going to pass the game. And this is a little bit complicated because we have not written the game yet. And so one of the things that's very important, like I've said many times on the stream, is you always want to write the usage code first, and we are at a bit of a disadvantage because since we don't have the game, we don't actually know exactly how we're going to be using the user input. If the game was done and someone handed it to us and said, hey, here, make a platform layer that supports this game, well, we could very easily see what the optimal way to pass that input to the game would be. We don't have that, and so we know going into this, and it's important to know these things, we know going into this that what we're doing here is a first pass. This is a first pass attempt on the interface. Time for some almond milk. Bit of a long swig there. If you are drinking along at home with your own almond milk, I highly recommend taking a pretty strong hit. Sometimes it helps, especially when you have a cold. All right, so basically what I'm trying to get across here is API design and platform layer design and just code in general. You always need to have a little bit of a consciousness. You have to have a little bit of a voice in the back of your head that lets you know exactly what it is you're doing at any given time. Because the type of code that you're going to type in is going to be different depending on the circumstance. And the circumstance in this case is we are iterating towards the API that we want, which is not the same as typing in the exact final API. The reason this is important is because it means you have to let there be a little slop in there. It means that you have to not spend a lot of time on a lot of the code. Now, you'll notice that our Win32 code is pretty darn janky. That is not because we're being lazy. That is because we're trying to save ourselves work. We know we're going to rewrite a lot of that stuff when we go to tighten it down for shipping, and the time that we would spend tightening it down now would just be wasted because it would all be deleted. So we need to remember what kind of code we're writing. We need to know what kind of standards that code has to be up to. We need to know what kind of future that code's going to have. And all of those things in the back of our head informing us with how we should proceed are very important because they'll save us work. Doing too much analysis and too much work on code too early in the process is bad. There's the old adage, premature optimization is the root of all evil, and a lot of people take that to mean that the optimization is making code fast. Well, that may be true. Doing that at the head end might be bad. You might spend a lot of time doing optimization on code that didn't need to be optimized, or that you optimized in the wrong way because later you change it and you have to undo it all and do different optimizations. That's all true. But what's also true is that optimization really in this case, for purposes of the adage, can refer also to the design of the code itself. Premature design is one of the most, and I repeat, most destructive forces in computing today. It is the thing that costs the most time. It is the thing that results in the most problems in shipping code. Premature design is awful. You have to remember what you are doing at any given time. So right now we are at the beginning of the design phase for this API, and we need to understand that these are experiments, and we need to use them as such and guide our code up to the point where we can start to do final API work on it, and that is the time to start tightening down crossing the I's and dotting the T's, or crossing the T's and dotting the I's, depending on which language you happen to be using. That is the time for that. Okay. So,
what's it called? The input looks a lot different here. How would I? Let me have a look. In the game, where's my input? I think essentially I would just, so I don't have a gamepad to connect yet. So I could move this. This would be part of the game. The same for this. I think for now, I could just leave this out. Excuse me. What does it return? Key symbol. What is ULO? And see. It's a long int, so it's an int 64. Unsigned long int. The data type is stored no negative whole numbers and typically has a range from 0 to 4 million. Long is 32-bit. On systems where long is 64, the range extends up to that. Okay, so it's basically just U64. Let's copy that and build some buffer. Build key press. This doesn't need to return anything. But escape. I mean, for now, I'll leave it there. This would need to be public. Get rid of this, get rid of this. If key symbol. Escape, then do this. Second of key symbol. Expected 2 arguments. Pointer to global sound buffer. Okay, I mean you can ignore the clicking sound in between, because right now it's a blocking operation. Okay, that'll do, because I don't know how. I think escape will not quit the game. That will be handled separately anyways. But for now, I'd like to have it close the window. This is convenient. Okay. I mean, that's how I would do it. See how Casey does it.
Basically what I want to do here is I want to start to imagine what would be useful for my game in terms of input coming from the platform layer. Now I know that this game is not really going to care too much about which controller you're using, keyboard or joystick. It needs to be able to work with both a keyboard and a gamepad, that's true. But I do at least want to know, for purposes of tuning, whether the user is using a gamepad or they're using a keyboard, because at least for movement, where one of them might be analog and one of them might not be, I kind of want to know this. So I feel like I'm going to at least want there to be something, like the input dot is analog or something. I'm going to want to be able to do some checking on something like that. Right? And I'm going to want to be able to do things in here that are like use analog movement tuning, and in here I'm going to want to do use digital movement tuning, right? And so I'm going to expect there to be differences in how I might want to tune the motion of the character based on which one it is. Now, for the buttons, I don't expect that to be true. For the buttons, you push a button on a keyboard, you push a button on the gamepad. For the purpose of this game, I think those are going to be roughly the same, so you won't need to tell the game about that. But for the stick, I'm going to want that. So again, just pie in the sky, I'm just saying I want that. It's got to be in there. Whatever this thing is going to be, it's going to have to tell me that piece of information. So we've got that. Now, I'm also going to want to basically be able to look at that motion of the stick. And now what I've got to think about here, and maybe I'll bring up the diagram for a second, the awesome Microsoft Paint, one of the most powerful paint packages in the world, certainly the one that most game art is made on. Microsoft Paint, everyone knows that. Professional paint artists love their Microsoft Paint. So in here, basically, you know the ubiquitous arrow diagram that I draw every time. This is time here, T going forwards, and we've got frames, right? We've got frames worth of processing. So in here, this is frame 1 that we're processing, or actually let's call it frame 0. Let's start at 0 like a good programmer would, and going forwards. Now what we have to remember is the user is viewing a frame basically after we compute it. So if this is which frame we're computing, right? If we're computing frame 0 in this time, it's actually going to get displayed here, and they're going to view frame 0 here, right? And then they're going to view frame 1 here, and they're going to view frame 2 here. So it's always kind of going like this, right? Oops, made that arrow go a little too far. There we go. Can't blame Microsoft Paint for that, people. All right, so basically what happens is if we are computing during this period, let's say, or we'll actually use it after we're sort of up here. So we're displaying frame 0, and during the time when the user is looking at frame 0, right, they are moving the joystick around, right? They're moving the joystick left and up, and who knows, maybe they roll it around. Now, they've only got a 30th or a 60th of a second. They don't have that much time, but they still could be doing some small amount of motion on the stick in that time, right? They might slightly move it, you know, from you know, if the stick is one of these things and it's over here, right? You could imagine that in a 60th of a second, if you were really wailing on it, you could wail it down a little bit in a 60th of a second. And especially if we're going at 30 frames a second and we've got a 30th of a second to do that, well, they might be able to move it twice as far. They move it even further, right? So the user is moving their joystick in response to what they saw on the screen. We're not going to get this input until after we've already computed frame 1. So the next frame they're going to see is not going to incorporate any of the input they were doing when they actually saw frame 0. This is one of the reasons that having a high frame rate is good, because basically you have to act on the input that you got last frame to compute this frame, which means you're always essentially 1 frame behind. If you do your input stupidly, you can even be 2 frames behind, but no matter what you do, it's not instantaneous, the response. It's always bucketed by that frame rate, and you're going to be 1/60th of a second behind, possibly more, depending on the circumstances. So we have some decisions to make here. Now we got another thing, which is like, let's say they push the A button, right? They push the A button down, then they let up on the A button, then they push the A button again. Probably pretty hard to do that in a 30th of a second, but who knows? Maybe they're really wailing on it. Maybe they got magic fingers. I don't know. Maybe they hooked up one of those old turbo joysticks that does the automatic repeat fire. I don't know. Who knows what could happen? But point being, if we imagine this frame to be impossibly long, let's say we were running at 1 frame a second, then you can certainly imagine the user pushing the button a couple times during that 1 second. And of course, that is something to be aware of as well. And so what we need to do now as a game is we need to decide what about this series of operations that is happening in here do we want to actually record? So like, what do we save, right? And of course, we have some restrictions on what we can save because the joystick itself is only polling its own state for a certain number of times a second. So we actually just get snapshots. You know, what we get if we look across this, depending on the polling frequency, is we just get a series of little positions of the stick, right? We don't actually know what happened in between there. We don't know what happens in between the polling frequency. So no matter what it is, it's kind of a discrete approximation of the actual motion that happened on the stick. Same thing with the button. If somehow the user could press the button twice fast enough that the joystick itself wasn't polling fast enough to catch that, you could imagine a circumstance where a button press was completely missed, right? So there are limitations of what we can do, but certainly what we do want to do at a minimum is ensure that anything that's important for our game to have happen that we don't miss. So for example, if the user happens to let up on the A button here, press down on it, and then let up on it again, that's a button press. We don't want to miss it. We never want to miss a button press because then the user pressed the button and didn't shoot or didn't do whatever it is the game's going to do when you push that button, and that feels awful to the player. So we want to respect those things as much as possible, okay? So what we need to decide now is how we're going to collect this information and how we're going to pass it on to the user, because we can always decide to poll those devices more frequently if the operating system lets us do that, or try to get access to lower level data. We can always try to improve how we get the data, but no matter how much of the data we get and how accurate it is, we still are always going to have to solve the problem of how do we encode it properly so that when we pass it to the game, it has the easiest time understanding it. Okay, so what I like to do in general is I like to think about what the possibilities are for the various things in the game and on the joystick. And the first one I'm going to talk about is basically looking at sort of what people will often do, and then I'm going to say why I often don't do that thing, sort of as a compare and contrast. So what people will often do is they'll often do something like this. Well, you know what, and I can write it in code so you don't have to look at like an interface. You can actually see what the code would look like when they write it. They often do something that looks something like this. You've got a for loop, and it's going to do something like, let's say, event index equals 0. If that is if I can type tonight, which who knows. Event count plus event index like this. And then they'll go through and they'll have something that's like an event array, and they'll look into the event array and they'll do like switch event array, what type of event this is. Oh, it's, event A button or something like that, that sort of thing. So they'll have like a type of event, or the events will just be the state of the joystick. So basically it'll just be like, oh, okay, there's an event index and we've got the stick X in here, right? Stick Y in here, that sort of thing. Whatever A button is either up or down, that sort of stuff. And basically what happens is, again, it's a very minimal amount of processing that the platform layer does, and the platform layer basically goes ahead and takes its information, does the minimal amount of processing on it, and hands it over to the game and says, here you go, you look at the series of polling results and you figure out what's going on. Now, the thing that I don't like about this is that it has an inherent kind of limitation in it that forces us to think about something.
Limitation. No idea. Can't tell. I mean, it's not too far from what I've done. Yeah, let's see.
And that limitation is you've got to have somewhere to store these events. And the number of them that you choose to store determines exactly how many times the buttons can be pressed inside a given frame. Now, that may not sound like much, and it isn't, because memory is really cheap nowadays. You could just have 10 megabytes of button store and go to town on your little party, and then no matter what the user was doing or no matter how long the frame took, you will not be able to generate enough events. Even if you're polling at some, if it took 1 second long and you were polling at, 1,000 hertz, well, 1,000 events is not going to be a really huge deal. But in my mind, I still tend to think of it as, why would I incur the downsides of having a variable length set of storage if I don't need to? And so what I ask when I see stuff like this is, do we really care about that? And for this particular game, I don't know that I actually do. And so what I like to do is I like to do something more like having the input just say something like, let's say, A button started down, right? A button ended down, or something like that, and a number of transitions or something, right? Because what I can do is I can essentially turn any one of these buttons, right, into something. Let's say the button, let's say that we have over time, if this was a diagram of our A button, this is up and this is down for our A button. If over the course of the frame it started up, pressed it down, went up again, they left it up, they pressed it down again, then it went up, they pressed it down, right? Then basically I know that I can encode this signal, right? This like up, down, up, down, up, down kind of a signal, right? I know that I can encode this signal by just saying how many of the transitions I went through, right? I can just say how many times it went from up to down or down to up. I can just treat that. I can treat that as one or transition, or I can count half transitions, right? I can count down to up and up to down. I can count that, so it'd basically be 2 transitions or 2 half transitions per press, right? Half transitions. And if I encode it as half transitions, I can basically say, well, all I need to really know is what state the button is at the end, and then I know the number of half transitions tells me what the state was at the beginning. So basically I'd have 2 things I need, which is the button down now, and how many half transitions did it go through for the course of this frame, right? So what I want to know here is basically, okay, do I ever actually care about subframe resolution for the button being held down, right? Because what I lose by encoding it this way, what I lose in this encoding, is if the user was able to differentiate between, say, 120th of a second press, that's this long, and one that's like a 240th of a second press, which is like that long or something, right? I don't know. I'm drawing this poorly. This diagram has gotten out of control. But you basically know what I mean. If this was our time here, right? And I've got, this is 1/60th of a second right here, right? Then as I go through this, if I was to look at the button press going from up, so the button is up, and then it goes down for a whole 1/20th of a second, this region right here, do I want to differentiate between that and something that just looks like this, right? Where it's down for only half that time. And my answer to that is I don't think any player can even do that, right? Players can't really distinguish between a press that's a 60th of a second, a 30th of a second. Maybe they could at a 15th of a second, but intentionally, that's not really going to be the case. When we're talking about the difference between a button hold and not, we're talking about a hold across many frames, I think. So a hold is going to be, you know, a quarter of a second or something like this, or an eighth of a second. And that's going to be across many frames. So at that point, I tend to kind of think of it as, well, I don't really think I want to try and track that, and I don't know if most operating systems are even going to give me anything at an accuracy that...
Okay, that just reminds me. I mean, it seems too early to be able to worry about it. Whoa. What's button press and release? Anywho, I think at some point... Yep, C dot key release. Some point. That was weird. Why did I get a Discord message? Yeah, because right now it's way too simple. It only changes the tone, and it's not very real time either. I think it only updates the tone every second, so it wouldn't really matter. Yeah.
would even let me see that, so I think it's probably just a waste of time to encode it. Okay. So what I'm going to say is I basically just want to try something that's basically like the A button started down, you know, and the A button half transition count. And that's all I'm going to do per button. So if we had 4 buttons, we'd have 4 of those, right? So I'm just going to go through those, and we don't actually use the button right now for anything. We'll have to invent something for it to do. But basically, I guess what we'll do is we can do something like, and I wanted ended down, not started down. Basically, for now, what I'll do is, since we don't have anything else to do right now, I'll basically just say that if the A button ended down, I will make on any frame where you're still holding it, I'll make the green offset kind of increment by 1 or something like that, let's say. Just for now, it's not a good example of doing anything useful. Once we get some like projectiles or something, we can start doing some real coding there where we look at the half transition count and launch as many as we should and things like that. But for now, we're not going to do that. All right, so we did that, right? We've got the A button down and the half transition count. That's what I'd like to do for buttons. Now the stick. And the stick is a little more complicated. because it depends what we're going to want to do with it. If we had a D-pad, it'd be a little clearer. I think if we knew that we were going to be on a machine that had a good D-pad, I might want to do stuff like allow you to do that old dash thing that people used to be able to do. Do you know the one I'm talking about? Where they basically could like double-click this thing in a direction and you dodge. You know, I'd love to have that. I'm worried that that is too difficult to do. I'm worried that's a little bit too difficult to do with an analog stick. I don't know. What I do know is analog sticks are so clumsy that no one's probably going to be able to do much in a 60th of a second with that. But the reason that I mention it is because I'm a little worried about how to capture that motion if we were going to do quick dodges. And the reason that I say that is basically because if you think about what we're trying to do here, let's say we were polling fairly frequently. We got a 60th of a second here, right? We've got this 60th of a second. And basically, let's say we were polling at some kind of a thing like 1,000 samples a second, right? So basically, we're talking about having 1,000 samples a second, and we've got 60 buckets into which those can fall. So there's actually 16 samples like this, right?
I mean, that sounds way too short. It's like 16 milliseconds. I read somewhere that pro players, I think the reaction time is like 120. So you only have to worry about things after which are greater than 1/10. Yeah. Maybe.
Okay, there's our samples. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So they each go one sample in each of these buckets, right? We got a stick position in each of these buckets. So let's say that we were polling at some ungodly frequency because we're trying to be Mr. Amazing Action Game, and we've got some crazy, you know, the dude spent $8,000 on his Razer massive joystick thing that pulls perfectly, and for Street Fighter he's playing at Evo, God knows what's going on. We're trying to do that, and we basically want to look at this and say, well, okay, so what happened here was he started whaling the stick right here. So basically the stick at this point, and so from this point to this point, went from neutral, right, to basically whaled all the way over. He just full-on slammed it, and he's got magic fingers, so it went really quick. Then he released the stick, and it returned to 0 here, right? Well, the problem with this is if I'm trying to detect it, if I average the stick value over this time or something to pass to the game, I'm going to get an average that's like somewhere, you know, in the middle of that range, right? And this could happen even in a wonky way across frames. You know, you could imagine something where, like, I've got a situation like this, where the stick was held this way across 2 frames, but here it's dead and here it's dead, right? This, again, the average of these is going to be something that never shows the stick fully whaled, right? It's always going to be half whaled, and know who cares about half whaling? Nobody half whales the stick. That's not even a phrase. No one's ever said I half whaled my gamepad. That's not a thing. Got that kind of caught. You kind of caught a little bit. You see that? You got to hold it back. You got to. This is how you do it. If you got one of these bottles, you got to hold that back, and then you know what I'm saying. Those of you who have these know what I'm talking about. Otherwise, it gets up in there, gets all up in your face, and there's nothing you can do about it. It's too late at that point. There's no recovery possible. All right. So basically, what I'm worried about here, if we were just doing, you know, I don't want to tip my hand too much here, but let's just say that Legend of Zelda or Binding of Isaac were in the realm of things we were trying to do here. And we want to move a little character around the environment in like a top-downy kind of way. If all we were doing was cloning those sorts of games, exactly, I would say, does not matter. That kind of stick movement does not matter. We'll just pass the average stick, and we will be fine. But because, like I said, not tipping my hand too much, I'm not really doing exactly that, or at least I'm not planning on doing exactly that kind of a thing. we have a little bit more to worry about because I might want to try to get some stuff working that involves these kind of tap motions. A quick tap. Maybe not a double tap, but at least that one quick tap. So, what am I going to do? What am I going to do? And the answer is, I think, for purposes of this, I'm going to go with a stick interval. And this may be a bad idea. It may be that I should just shove 16 samples down the thing at a time. It may be that I should switch to an event thing, like I said. But I don't know. I'm not sure. I think I might just want to go with some kind of stick interval so you can kind of see how far the stick moved, that kind of a thing. So like a min-max sort of a thing, if that makes sense. And so what I think I'm going to do is I'm just going to go with an input kind of thing where it's like we've got a min x and like a min y kind of a thing, and they'll have max as well for the stick, that kind of a thing, right? So that I can basically see where the min and the max was, and then maybe where you ended on, right? And so the same as before, end x, right? And I could even do a start x as well. So we could basically see where it started, where it was in the middle, where it ended, right? That kind of a thing. I don't know. Like I said, experimenting, totally being experimental here. Not saying this is the right way to make a game. Not even saying this is the right way to make this game. I'm just saying that's what I'm going to try, and we're going to see how it works. So, how does that work in practice here? I want to write the usage code first. I want to basically take our tone hertz, right? I'm going to take our tone hertz here. I want to update that. So I'm basically going to take the tone hertz and say that the tone hertz is going to be plus some small amount of wiggle, basically that's going to be on there, right? I'm going to do this in floating point because, as you'll see, we're going to actually start moving almost everything to floating point pretty soon. But we're still an integer here, so I'm just casting back to it for sake of our tone hertz. Again, one thing at a time, always one thing at a time. And I'm just going to go ahead and say that whatever it ended on again, because that's the easiest thing for me to do at all times, and we can trivially test to make sure our thing is working at all by sort of going there, right? By getting that to work. So I'm going to make our tone hertz be that, and then I'm going to make our blue offset be plus equal to, let's say, whatever the int is of, I don't know, let's say up to 4 pixels at a time, maybe, times whatever that stick is. What is that stick going to be? That stick is going to be end y location, right? And that is what I think I'm going to want. That should basically work for the most part, I think, except for the fact that I don't actually have anything defined yet. But it looks good to me. So I'm going to go ahead and say game input is here. And basically what I want to do is I want to blow this out a little bit because I feel like we're going to have a situation where, well, what if we want to support multiple players, right? What if I want more than one player at a time? Basically what I want to do is say, well, this input thing, whatever the input thing is, the input equals like, the player 1 input, right? I want to be able to get just player 1, let's say, for now. Later we'd have a way to like join and know who was joining, but we kind of want player 1 input probably, and then we just kind of go and say, well, whatever player 1 input actually is, then we'll do that. So maybe input is like a game controller input, and we get that back. We take the random thing, we say input, and we say input. I guess we should say 0. So player input 0, something like that. I'll just grab out of an array of inputs that will say however many players we support, maybe 0, maybe 1, and then I'll say we know that that's accurate, right? There we go. We know that that's going to work, so I don't really have to test anything. Then this is going to be a pointer input 0. I want to know if it's analog or not. I'm not really doing anything with that yet, though. Well, there is one thing I could do, which we could play around with, which is which one of these we're going to do. So for the moment, we could say that we'll use is analog there. Let's do that. That'll be good. And then we'll also do our button thing. That happens whether it's analog or not. We'll do the digital movement there. Just trying to think through if there's anything else we needed. That's fine. With A button ended down. That all looks pretty good to me. So I'm going to say let's go with that for now. Let's just see how that works. Make sure that there's nothing particularly surprising going on in there. we'll just see how that works. So I'm going to say we've got this game controller input thing. The game controller input is going to have the things that I talked about. I also probably want something like this. Game button state that'll have the half transition count and the ended down flag. That's actually going to be a Boolean for now. So I've got some button states. I know that I think I said that I wanted 6 buttons on this thing, the 2 shoulders and the A, X, Y, B. Now I don't know how I want those to be right now. I am not sure, so I'm just going to call these up, down, left, right, let's see, and then left shoulder and right shoulder, like that. I'm just going to say that that's what those are for now. We might want to put them in an array later if we decide we want to, if it makes things easier. I could also make a union out of these. I could do something fancy. For example, I could do this. If I was Mr. Crazy Town and wanted them to be accessible in both ways, I could do something like this. I don't know if that makes any sense to you when you take a look at it. Maybe I'll do it just so you can see how that's going, assuming that I typed that in right. We'll see in a second. The game input will just have a bunch of these controllers because we might want to have some controllers. Let's just say that these are the, I guess we should call them controllers, not players, because they're not really mapped to players. We'll say that we support 4 controllers coming in. We're going to maybe need to do some work on that in the future to make that a little more robust depending on the circumstances, but we'll just say that's good, and then we'll just do controllers there, right? And so that's sort of what I'm thinking. Then we obviously have some floating point values here. The floating point values are the stick X and stick Y. There's some stuff that I probably want to do with that in the future, but I'm going to leave those as X and Y's right now because we haven't really talked about vectors, and don't want to jump right in with vectors if we're not ready for them yet. Min X, min Y. But those of you who know what vectors are, you pretty much know, you can see it coming. I think when you look at that right there, you're pretty much going to know what I'm talking about when I say the vectors are coming. All right. So, oops, got a little semicolon there. Gotta actually pass this stuff to the actual thing. So gonna need to pass my game input, and we'll just go ahead and send that in this way, nice and clean. And we will delete those extraneous, erroneous parameters. We now have that going for us. Put that in there. Lovely, lovely, lovely. Like one of those cooking shows when they put in like the basil and they're like, you know, starting to smell delicious. You can almost just feel the aroma of the fresh pasta. And they say all these things, right? And you get really excited about it and you're like, wait a minute, I'm not going to eat that at the end. That's one of the things we have, ladies and gentlemen, over a cooking show. If you think about it, you are going to get to play the game, the actual game at the end. You even get to have the source code at the end. It's like the cooking show reaches out and hands you the pasta. How cool is that? I mean, yes, okay, I charge $15 for it. I apologize. It is actually a commercial product, but that you can't like pay $15 and get the food on a cooking show, which, by the way, I would probably do if you could do that. If it just kind of came to you, you could have like a download link and you could like get the pasta. It'd be like, I want to buy that. When they have replicators, if Star Trek works in the future and you just like have like Gordon Ramsay cook some stuff and you push the button and like it charges you $15, but you get this whole meal, like that's like gonna be totally crazy, right? Like, how awesome is that going to be? Of course, it may make it harder to make cooking shows because the stuff comes out and tastes lousy. Everyone at home knows now. They can just lie, basically, right? And be like, oh, it tastes delicious. Maybe it tastes terrible, right? And you don't know. But anyway, so that's just all. We're like one step ahead of the Food Network here on Twitch, okay? That's where we're at. So this is some good stuff. This is the future, ladies and gentlemen. It's the future. It's the future of food in a roundabout way. All right, so basically where we're at is we're just going to have to now do the porting work necessary to shove this stuff down to the game from the platform layer, which shouldn't be too hard. Forgot one of the things I wanted, which was analog. So each controller is going to have a Boolean up on top, which is analog. There we go. That's fine. What is the problem? Not a member of controller input. What are you talking about? Did I mess that up?
Hey, Mojo. Me too.
Oh, nice. Didn't put the is in front of it. That's not going to help anyone. Okay, and so this is ended down. So we've basically got whatever the A button is, the button that points down. So that's the down button on our controller. And game update and render now needs to take one of these. Okay. So this is going to be a real straightforward thing here. This is not going to be particularly difficult. Basically, the only thing that we're going to have to do is for keyboard input, it's going to be a little janky, and I'll show you why in a second. But basically what we can do here for the most part is we can just go ahead and take this game button state, game input state thing here, and we can just cheese out entirely and go up here and say, all right, when we go to actually do, our message or whatever, here's our input state. Everything gets initialized to 0. Why not? For now, we're going to deal with that later. And basically in here, we can sort of do all the stuff that we said we were going to do. Now, we are only taking one sample per frame right now, so it's trivial to set up the things that we want to set up, like really, really trivial. That almond milk. All right. I need to get some kind of endorsement for almond milk. I like it so much. I don't know how I drink the store brand. That's the problem. No one's ever going to give you're not going to get the sweet deals, right? You're not going to get the NASCAR stuff where you got like the emblems on you for the store brand, right? Like nobody, that doesn't happen. And I just drink the store brand. So that's, yeah, what are you going to do? What are you going to do? You got to sell out sometimes, people. That's the thing. You got to sell out sometimes. All right. So basically we've got the
You're a bit bolder than me. I mean, not really, because I think I run Linux, so I was sort of lost for choice there. I'm doing C on Windows. Hey, pretty good. Day 20. Yeah, you're quite far ahead. Oh, yeah, about a week ahead. Yeah, I thought I'd like spice it up a bit by trying it with Zig and Linux. It's not that much harder, I would say, because once you understand the concepts, which Casey explains very well, it's just a matter of getting used to the API on a different platform. I did make it much harder for myself than it needed to be. I could have used STL. It's the same, what's it called, library that Handmade Penguin uses, the one that Casey links to. But I wanted to like stay true to Handmade Hero, so I decided not to use any libraries except the standard library from Zig. Yeah, but it's been a lot of fun, but it has taken a lot more time. I think I'm on day 13. I started a month ago, so twice as long.
D-pad, up, down, left, right. That's our stick situation. So we're basically going to have to handle these for our stick and take a look at those. We have some stuff we need to think about in terms of how we're going to handle that, but we'll think about that in a second. Namely, what the analog, how we want to answer analog for something that could be using both the analog or not analog. Hard to say. So we'll take a look at that in a second. We will also go here and do the buttons. So the buttons should be pretty easy. Basically,
yeah, because I saw the STL API. It felt a bit like cheated. It does everything for you. All of this is it's all handled. Yeah, and to be fair, I think the guy who wrote the port for Linux says that everybody uses STL. And I thought it's always going to be easy to switch to STL than the other way around. And it's not as hard as he said it would be. X11 is quite good, not too bad at all. And so is Pulse Audio. I think those are the system libraries that's on Linux. And they work pretty well. Except audio, it's a bit different. I think audio is a bit simpler. There's no ring buffer. I mean, there is, but you don't have to like deal with it. You just pass it a buffer, and then it plays the audio for you.
We can just do something like this. So we can say for our input, we have our button state, and our button state just has this. So the we have a half transition count, and we have whether it ended down. This is our button here, our button struct. There we go, button. Okay, so basically what we need to do here is if the button ended down, really all we need to know is was it down before, and if it was down before, then there was a half transition. If it wasn't down before, then it wasn't. Really not a whole lot to it. So basically all we actually need to do is say something like, was it down previously, right? Like we don't know. If it was down previously, then the half transition count is 1. If it wasn't down previously, then it's 0. Or I should say more specifically, if was it down previously, it equals whether it's down now, right? Something like that, right? Make some sense? Hopefully that's pretty clear. So basically, if the button was down previously and now it's not, that's a transition. If it wasn't down previously and now it is, that's a transition. And then whether or not it ended down is just the state of the button. So that's just going to be something that looks like that, right? So what we can do, we've got a lot of buttons here. What I'd like to do is basically generalize that out so I don't have to type it that many times. So basically what I'm going to do is I'm going to say something like this. I'm going to go up here and say, well, I've got an internal function, and that function is, in maybe let's say process digital button, or process x input digital button, let's say. Because that will basically, yeah, there we go. So that will be our call here, and it will take the information that we need to do this processing, and then we'll just call it for each one. So this guy right here, I believe, is the D word normally. So this is the button bit that we've got, button bit. There we go. We've got the button itself, which is this thing. All right, this is the thing. We're going to call this new state. That's the result that we want to compute. And then we're going to have to pass it the old state as well, because it needs to know whether it was down and what's going on there, right? That's going to have to happen. So the half transition count is basically going to be if the old state ended down, right? Let's just say, and the new state ended down are not the same, then there was a transition, one half transition, up to down. We're not polling frequently enough to make that happen any differently. So in the future, if we do up the polling rate, that's where we'll put it. And we can probably do that on a separate thread if we wanted to. I've never really tried that with X input. I'm not sure how effective it is, but maybe we can play with that and see. I don't know if you can turn on buffered input in some of the later versions of the X input library, but like I said, I want to leave the platform layer a lot of room to get us better data if it can, so that platforms that do support higher polling rates will get that data. So that's something I just want to make sure that we're future-proof essentially down the road so the game can get that information. All right, so if it ended down is just whether or not this right here equals the button bit, right? Basically, that's all we're saying. If that button bit was high, we are good to go.
I'm thinking, how would I do this for keyboard input? Oh, I gotta get rid of this. This is... Gotta be able to call this here. Update sound and display. Let me create call it keyboard. Input is fine. I know the key that we pressed. Basically 32. Key released. What else can I get from the key event? Event data. Okay, so there's only key press and release. What does key release? The upper buffer is an area used by Xlib to store requests. The function described in section plus the upper buffer of the function would block or not return an event. That is, all requests residing in the upper buffer that have not yet been sent are transmitted to the X server. Okay, so essentially I could get all the keys pressed. Push the upper buffer and then wait until all requests have been processed. Use xsync. And I'll get back to that. Okay, so the press and the release event are the same type. Okay, what is time? Is how long the key was held down for, maybe? Okay. Millisecond. What if there's like multiple keys pressed at the same time? Not sure. Because that can be a key as well. is then for key release do 0, and then I can add save the time as well. Let me see how long. That's 64. Could be. Okay. I can get rid of this. This render game. Not this one. Vault. Game update and render. I'll give it input as well. The handmade dot. Okay. And then here. No key event. Password input. And then some buffer. Doesn't need to be public anymore. Should be Okay, time is not a pointer. 120. $87. Oh, this is a pointer. Yep. Cool. Still works. I still have to run. No, this one. I think I still have it to do. Right. Audio. Yep. I still gotta run this in a different thread. I think that will take care of the clicking. So right now it blocks every time it writes audio. Okay. I mean, it's not the same. I don't do anything with window. Released. But I think it's right now not needed.
I think that's about all we need. That is looking pretty straightforward to me. So this is new state ended down, new state half transition count, old state, looks good. So now we've got this digital button thing here. Oh, that's right, and we need the actual button state. So X input button state. We need to actually look at that as well. So that's X input button state. So that's all we need, I think. Then we come down here and we actually go ahead and process all these buttons. So we've basically got a call here. It's going to be passing the button bit that's appropriate for it and the button state, which is pad W buttons, right, like that. So we're going to do that. Then we need to take our input. So this is our controller, and this is going to be a particular, this is old controller, I guess, and its state. And then we're going to do new controller and its state, and there we go. And then the button bit, right? So then I just blow this out for every one that we need. Not particularly tough. Basically, I've got the A button there. What else we got? The B button. Sometimes I like over-pronouncing the word button. Button, right? It's very satisfying. Button, button. As far as button, when you kind of swallow it, it doesn't sound as proper, right? It doesn't sound like you really mean it. You didn't really care about the button, but you cared about the button, right? You know what I'm talking about. Anyway, so basically all I did here was I just cut and pasted that code there so that we can basically crack things out. Now, I'm not actually tracking the start and the back button because I'm not sure if we actually care about those. So we're just going to leave those blank for now. Nothing particular happening there. And then we got to do our dead zone processing up here as well, which we'll do. So basically what I need now is I need to get these things that I was talking about here. So old controller, the state for the button is going to be each one of these. We said the A button points downward on the controller. Yes, it does. So that's old controller down. Then we've got the Y button, which is the up button. So that is this one, right? Then we've got the X button, which is left. That's left, and we've got the B button, which is right. So there we go. Now we just basically crap those out, and basically all we've done here is just made a reusable piece of code that we can call, so left shoulder as well, that we can call to crack all our buttons for us, so we don't have to keep copying pasting the code. We can basically just make this like a table basically that goes through each one for us, and we're all good to go, right? So that should be fine. We just now need to get the controller state. Now, fortunately, we know that basically this x user max count here, what we want to do here is say controller max controller count, controller count equals x user max count, right? And I just want to make sure that if someday they add more controllers, so if the max controller count is actually higher than the number that are in this right here, then input.controllers array count. I will tell you how to write that function in just 1 second. If it's greater than that, then I want to basically make it be equal to that. This is just basically capping that. Let's say the x user max count was 12. I don't want to get into a situation where I'm filling out right off the end of this array by writing into the 5th, 6th, 7th, 8th, and 9th elements and so on. So I'm just going to try and cap it here and say it's the maximum value is either the max count of x input, or if that's too high for our input, we'll make a smaller one. All right. So I'm going to tell you about how to write this array count thing in a second here, because actually C doesn't do that for you. It doesn't tell you how many elements there are in a static array, not static array, but in an array that's fixed size. It doesn't have a way to actually tell you that. So you got to write that yourself, and I'll show you how in a second. It's real easy. It's not hard, and it can be done at compile time. So anyway, we're going to do that. We're going to go through the max controller count. We're going to go over each one of those, and at the top of this, we're basically going to say, well, all right, we've essentially got the game controller input is the input that we're going to be looking at here is the old controller is going to be old input, which we'll have to save, old input controllers like that, and we'll do new controller state, there we go, is new input, so I should actually also make this be whatever the one we're writing into, like that. Let's do it that way. New input controllers, and we're going to take the controller index, we're going to grab those out of there, right? So we're going to get those, and we're going to write into them. And there we go. So that should give us what we wanted to do, and then at the end of it all, when we're done, we're just going to swap those two. So at the very end here, when we're done, we're going to want to swap our inputs. So we're going to want to do something like
Handle the gamepad later.
Like game swap, swap pointers or something like that. Well, I don't know if I really want to do that. We'll make it a macro for now. This is the place where I really wish I had metaprogramming. This is the place where people often use templates. I don't really like to use templates. I'm a metaprogramming sort of fellow, but if you had templates, you'd use them right here. I'll just write it myself for now, and we'll think about what we want to do for stuff like that a little bit later on. I'll put that actually up in here. I'll just put a to-do. To-do. Swap min max. Macros? There you go. All right, so in here we're just going to do the game controller input thing, this game input. Temp equals new input equals old input equals new input, and we will leave it at that. Now, whether we need to clear these, I don't know. To do, Casey, should I clear these here? Possibly we should, and we'll think about that in a second. But basically what I want to do now, like I said, is I basically just want to have 2 input buffers, and so I can look at whatever the last one was, because that's something that I wanted for button up, button down. So basically what I'm going to do is I'm going to go look at that input, that game input thing, and I'm basically just going to define 2 inputs, right, structures for the game input, and I'm going to say that my new input one, right, equals input 0, and I'm going to say that my old input equals input 1, like that, and that way I can just swap the pointers to them later, and it'll be fine. X user max count. Oh, did I accidentally delete something important from that? Let me take a look at the X input documentation. Oh, well, you know what I could actually do? I could guess. I guessed correctly. I'm going to show you how to write that one in a second. What is the problem here? Connect button state to button state star. Oh, okay, right. These just need to pass the address of it because they are taking a look at the address. I could not bother to pass the address of the first one because you're not writing into it, but who cares? All right, got that one. Game update and render is going to take the new input always, and then the array count All right, so I think we are, 1 second, my screen has blanked out here. That will make it hard for me to read the questions. Let's see. There we go. Okay, so for swapping, that's always good. All right, for swapping, I'm just doing a swap here. Basically, this is just, we should have a function that does this. What I wrote at the bottom here was I wanted to basically just ping pong between two buffers. I wanted to use one buffer and leave the old one around, switch to using the other buffer so that it would leave the previous one around, so we'd always have access to the last buffer we used in the previous frame. So all I did was I can't say, you know, new input equals old input, because now when I can't say there's nothing left. It overwrote what the value of the pointer to new input. I have no pointer to it anymore, right? So that's a bummer, right? If that makes sense. So basically what I had to do is I had to first snap a pointer to what new input was, so that when I overwrite the pointer new input with the pointer old input, I have the temp back, right? Does that make sense? Yeah. Really what I wanted to do was say swap new input, old input, but I wanted to kind of wait until we actually write a swap function to do that. So I'm just doing that temporarily. So now we have to go and take a look at this. Okay, what is the problem here? Missing semicolon, yes indeed. Okay, so now I just got to teach you how to write this guy, and then we have the start of our input. We might have to go a little long tonight. Looks like we're a little behind schedule from where I would like to be. All right, so basically defining this guy, array count, and it takes an array. Oops. It takes an array. All that this does is it basically just asks for the size of the array, whatever the array is. That's the total size of the array. And then we're going to divide by the size of the 0th element of that array, because that tells us how many there are, right? The total number of bytes used by an array divided by the number of bytes used for a single element, that gives us how many elements there were. So that's all I'm going to do. That's it. I don't know if I can bracket this. I'd like to bracket it. I don't know if I can. I can, so that's good. Basically, I wanted to make sure that I have everything bracketed, because basically in a macro, this thing is going to get inserted into here. And so if it was something like an expression, that I didn't want the 0 to, like, you know, if they passed in something like, if I had this and they passed in something like foo plus bar, right? I didn't want that to expand to foo plus bar, because then the 0 is only on the bar. I wanted it to expand to something like that. So you kind of have to be careful in macros to always put parentheses around more things than you would ever have had to in another case. All right, so let's see where we're at here. That was a lot of code very quickly, but it actually works just fine. I'm pushing the A button, and it's going up there. All right, so that works just fine. So really the only problem that we've got right now is our stick. And so we've got to get our stick in there. Now the stick has a thing called a dead zone, and I guess I'm going to have to defer that processing till later because we don't have time. So we're still going to say to do. And basically what I'm going to do is I'm just going to turn this stick.
Okay. I think could go ahead. Yeah, I think so. Alright, I'll leave it for tomorrow. Independent game memory. I mean, it's not the same how Casey's doing it and how I handle on my end, but I think the idea is the same. It's close enough. So I'm gonna call it yep, okay, that's still what to do. Platform independent keyboard. No, input. Yeah. Okay, so the input looks very different from Win32 because this is X11. Yeah. I guess this could just be calculated on a different platform. And yeah, okay, I think it's pretty good. Quite happy with that. This looks a lot cleaner now, the main loop. Least time, how long it was held down for. Okay, I think tomorrow I'll continue with day 14. That was quite fast. I think day, what was it? Sound day was the worst one so far. Took about 5 days. Mostly because I messed up the Pulse Audio API. Alright, I think I'm gonna call it a day. Thank you as always for hanging out. I shall see you back here tomorrow. Bye. Have a good one.